supply chain analytics team, and I think there's a lot of application of GIS for supply chain particularly, so I'd like to see, I'd like to learn more about it. Thanks for doing this, Matt.
Oh yeah, I'm glad to prattle on about GIS. I know you've got an earful for me over the years, and probably wished I wouldn't talk about it so much, but it's all good. Thanks for joining. Rick, go on ahead if you can hear me.
Hey, Matt. This is Rick. Work for SCCA. Met Matt at SCCA convention and at SoloNets, and we started talking about he had done some heat mapping for attendees at SoloNets, and I had the region mapping on my list for probably close to 6-7 years. And Matt pretty much launched that for us with some guidance on what we'd like to see. So eventually he needs to hand over the reins to me so that he doesn't have to spend all his time doing it. So I'm here to learn as much as I can and get started.
Awesome. Thanks for being here. Steve, can you hear me? Can you just introduce yourself and tell us why you're here?
All right. Can you hear me okay?
Yeah, we can hear you.
Yeah, okay. Yeah, Steve Hudson, met Matt through autocrossing. Just interested in learning more about GIS. I don't really have a specific application in mind, but I'm sure I'll think of something to do.
Awesome, and thanks for being here. And last but not least, Thomas, can you hear us? Please just introduce yourself and tell us why you're here. All right, yeah, Thomas, feel free to jump in whenever you want, but I'm gonna go ahead and move on a little bit while we wait for you.
All right, can you guys hear me?
Yeah, what's up, Thomas? Go ahead.
All right. Thanks for doing this. So I met Matt through friends of friends. My wife and I moved to Austin about 4 years ago. My interest, I work in consulting for a consulting firm, McKinsey, and I work pretty much in all marketing and sales. And I do a lot of mapping with everything like social media data like here. And I mainly use Tableau. So I've talked to Matt, I think once upon a time about how to use Tableau. So I do that for a lot of the clients that I have in consulting. But always after data sets to match with stuff. So curious, haven't seen anything like this. So just interested to learn a bit more about GIS stuff.
Awesome. And once again, I appreciate everybody for coming. I will try not to take up too much of your time, but I just want to kind of go through a brief introduction to the world of GIS and like how you can use it for your personal projects, or if you have any ideas and need some help with something specific, we can kind of get to that at the end. So to start off, if y'all notice, I have this nice little visualization. This is a thing that I saw at a conference years ago. The date is stamped from 2014. I think it was probably made around that time, maybe 2015, 2016. This is a really cool visualization of someone took this Twitter data that is geotagged. It's actually like a very popular API that people use to take data from Twitter, and they use the geotag location, the XY coordinates of those points, to make maps. This environment that you're looking at is it's an open source platform called CartoDB. It's a web mapping GIS platform, and there's a little time slider that you can see here on the bottom left. So this is just scrolling on repeat, but these are tweets that are going on that are tagged with the hashtag sunrise. And then there used to be this really cool visualization where it showed where the sun was on the earth. You can actually see pretty well at the tweet line. So right now it's going through Malaysia over here. It's about to hit India. And then
thank God, I thought it was alien sightings for a minute.
Yeah. So then it starts to get pretty big into Europe. And then, pretty nice little blip there. It's crossing over the Atlantic there. And then as soon as it gets to the States, it just kind of blows up. So I just thought that was a really cool visualization. I saw it at a GIS forum, and I kind of bring it up just to inspire people with like what you can do with GIS and just like a practical application of it that, relates to just your day-to-day stuff. So let's get going here. Yeah, today we're just gonna do a brief overview of GIS, which I've stated a couple of times. I'm gonna do a question and answer session. And then I'm gonna do the second session. I hope to do a couple of these if people are interested. And once again, if y'all are not interested, we don't need to do them. But the second one is gonna be how to get started up with GIS, like for your personal GIS environment setup. So that would be like either installing GIS software on your computer, which there are free versions and paid versions, whatever you want to do. And also there's a free online web mapping, and you might not ever need to download anything onto your computer. So we'll talk about all of those options and everything, and actually get into how you would set that up in the second session. So stick around. A little background on me. Once again, my name is Matt Peck. Some people know me as Matt Beck because that's my internet name. But I've been working with GIS for over a decade, and then I've been working for Central Texas local governments for over 6 years. Actually, one of my coworkers for my consulting stuff, Rick, is on the call. I've done a few freelance and consulting projects, basically doing ad hoc requests for GIS maps as people need them. People are interested in doing, little GIS projects from time to time. One anecdote that I like to say is when people ask me what I do, I'd say it's like 50% of the time they'll never have heard what GIS is. So I'll say, do you know what GIS is? And if they say yes, I'll move on. And if they say no, I'm like, well, I'm just in IT. So my current role is, it's called IT application consultant. I feel like that's kind of a weird title, but I mainly do GIS. I also do extract, transact, and load, automation tools, and then I do a little DBA, database administration and application integration stuff. So I do a little bit of everything, and that's a common theme you'll see in GIS professionals. We're trained to do geography, spatial analytics, and GIS, but because the environment of GIS covers so many like different technologies, you kind of become like an IT person as well. All right, so I sent this out in the email. I'm not going to read it verbatim, but at the core of GIS, all it is vector data, which are points, lines, and polygons that are associated with an actual on-the-ground coordinate that makes them up and is able to display them on a computer screen in a projected way. So everyone has their own different coordinate system. For surveying here in Central Texas, we use the state plane coordinate system, which is a very localized survey projection to make sure that there are no errors in a very localized setting. This is really getting in the weeds here, and I'm sorry, but all of the web mapping that you'll see in this presentation is in WGS 84, which actually covers the entire Earth. And the reason that you would use a world projection system is that it's very easy to use on a computer, and once again, it's a uniform projection for the entire Earth, so you can scale it up and scale it down, but you're going to have some errors based on the fact that the Earth is not a ball. It's very oddly shaped, and there's an entire field called geodetics. That's the word. People like spend their entire careers just like learning about like how misshaped the Earth is. So in this forum, I say that GIS encompasses a very large number of specialties, and kind of like I've alluded to in this introduction, there's like a lot of different things that fall under the GIS umbrella, like remote sensing, which is actually like flying planes and taking pictures of the ground. It's not new, but LiDAR is kind of a new thing that for like us normal people, you actually ping a laser down at the ground and you get a very precise elevation and color value, but you can use it to do like 3D modeling. Jacob probably knows a little bit about LiDAR, things like that.
Yeah, I thought it was when you pointed later, somebody could tell if they're lying or not.
I don't know if LiDAR can solve that need, but maybe. So also, yeah, surveying is a big deal. So I have a graphic on the next slide that shows who uses GIS, and I was really surprised with like how big the pie slice was for construction. I don't know why that amused me, but yeah. So surveying, I don't know if you've seen those guys standing out there like on the highway with the big yellow poles. They're actually doing probably RTK GPS surveying of like the actual location on the ground. I'm really getting in the weeds here, guys. Sorry. Once again, there's just a lot of stuff that generates GIS data. And so it's like this huge field. So we're gonna just like really stay at the basic level and focus on like the data that goes into GIS. So I gave some examples here in the slide of the points, lines, and polygons. If you can imagine, if any of you have done any CAD work, this is probably going to be a little bit familiar. CAD is basically unprojected GIS. I have a whole rant about people doing CAD and then trying to get it to GIS people, and it's completely in the wrong projection, but I'll save you all from that. Okay, so the actual GIS data is this points, lines, and polygons that we'll kind of explore in the future or in the next slide, but it kind of doesn't matter that you have that data if it's not on anything, right? So like I was saying in CAD and computer-aided design for like building design, things like that, it's just a white piece of paper that this is the data is overlaid on. So GIS, once again, it's the same situation where you have these coordinated points laid out on a screen. We overlay them over base maps. So base maps they also contain GIS data, but it's like a static map product. This is an old topographic map of Austin back from, I think like the 1880s or something. No, sorry, it's I was looking at a bunch of these today, but this is an old topographic map. You can actually see that there are streets on this topo map, and then you can see the Capitol building and some features like there's Mount Bonnell and Oak Hill, St. Elmo, stuff like that. You can actually see these things, but we don't necessarily care about that data on the base map. You use the base map to kind of orient yourself in the world of GIS, but it's purely for reference. The data we care about when you're actually interacting with GIS data are these the actual features that we create in GIS and then associate attributes to. So this is an example of something that Rick was talking about earlier. This is a region map. And so the need that this map solved was, okay, I live in Baton Rouge, Louisiana. I want to know what region I'm in and who should I contact? Where is the website to the SCCA organization that's associated with my region? So now you can log onto this map. You notice that Louisiana is on the map. You go to Baton Rouge, you click on it, and bam, this comes up. So one of the things that I glossed over, the reason that we have GIS in the first place is not only you care about the physical location of these points on the ground, but you also care about their attributes. So, let's say you have a pipe in the ground, like a water pipe that's going to deliver, it's a pressurized water pipe. It's in a water system, and then that pipe bursts, and you clearly see water coming out of the ground. You want to know exactly where it is so you can dig it up, and you also want to know what size it is and how many lines it has going to and where the valves are near it, so you can go replace it. And you'd actually know that data before you even go out there and dig it out of ground. So that's why we have all of this data assembled into a GIS. All right, so yeah, this is that graph I was mentioning earlier. This is kind of a crappy visualization, but I just wanted to kind of explain the types of people that use GIS. I did a little selection bias here, and I assumed the government was the largest user of GIS. I work for government, and I know of all the products that the federal, state, and local governments are producing with GIS. So I was just like, oh, I'm sure, it's got to be government. But no, there's logistics clearly is going to be a big one. Agriculture, all of the new like combines and all the farm equipment, they have GPS on board. They can be like driven remotely. They've got to know how much water is in the ground. All of that's related to GIS. Once again, another big sector here is construction. So you got surveying related to that and just designing everything. They're using GIS. Oil and gas, clearly a big one. And aerospace, defense, utility, all that stuff. So the reason why these companies use GIS, why anybody would use GIS in the first place, you're going to be a business or a company that needs to track assets, physical assets in the field. So for me, I work for a utility. So we have actual pipes in the ground, and we want to know exactly where they are and exactly how high they are in the ground. And we can actually get elevations using really high quality GPS devices. And you can also do things like asset management, which is a big deal in my job as well. So yeah, basically, if your pipe has been in the ground for 20 years, or sorry, 50 years or more, maybe it's time to replace it. So just kind of keeping track of all of those things. That's the kind of GIS I do, is all of this physical locations in the ground kind of a thing. And then, you know, regular people, just as a person, I use a GPS-based fitness tracker called Strava, and we're actually going to look at that a little bit later, but it tracks bike rides, and you can get your speed of how fast you were traveling and where you went and all this stuff. So these consumer grade applications based in GIS are using your smartphones or whatever to generate data that you care about. So that is another reason why people would use GIS. It's like real-time data. All right, so the types of GIS that we're going to cover, this is sort of generalized, but there are 3 types. We've got proprietary, which is, and I said license here. That means expensive, right? So there's this like 800-pound gorilla in the room. It's the industry standard. They're called ESRI or ESRI. They're the industry standard for doing GIS. Definitely in government, and then they're pretty popular in the private sector. On the flip side of that, and there's kind of like a debate in the GIS field, you either go full proprietary, you buy your license to Esri, and you get all these really cool things, and you get to design all of these products, but it's like really tied down to what they let you do. So there's a downside to having it. On the flip side, you get like technical support, things like that. So there's that side of the camp, and then the complete opposite side is full open source GIS. So that means you download all of these installs onto your computer, and if anything breaks, you have to figure it out. However, it is infinitely customizable. So you can like go full crazy, you know, do whatever you want, make web maps. Nothing is out of the realm of possibility. You just have to know how to, you have to be a developer and know how to code and everything. The third type of GIS, I actually, so in my personal and work stuff, I'm in the top 2. I don't really do full open source GIS. I've done it before, but I just don't use it very often. The middle one is proprietary / open source. It's not really open source, but it is free. That's like Google Maps and My Maps, free GPS-based apps like the Strava app that I was mentioning earlier. So you're going to do no customization in those. You can't build them out. They usually have limits on what you can do with them, but you can actually use these free applications to do a lot of GIS work that you normally wouldn't be able to do unless you had like knowledge of how to do open source GIS, or you had this like really expensive license. So we'll talk about applications of why that would matter in a little bit, but those are kind of like where you would fall in GIS. The middle one is going to be your typical person that maybe just needs to make a map, and that's all they need to do. Is they need to say, hey, I need to know the location of a couple things. I don't care about anything else. Going to cover GIS, the history of GIS briefly. This is a very crappy recollection of the history of GIS, but I'll start here. This is a really famous map that you'll see in every intro to cartography class. This is the Broad Street map. And it's actually pretty relevant to our current times because there was a cholera outbreak in the 1800s, and they were like, where is this thing coming from? And all these people were getting infected. And this guy named something Snow, I am really killing it on this history lesson. This guy named Snow developed this map, and he wasn't a cartographer. He was
his name is John Snow.
John Snow, thank you, Yukon. Yeah, Yukon and I were talking about this a while back. But anyways, they were trying to figure out where all this was coming from, so they made this map, which is actually a GIS map because it has attributes and locations, and it's actually pretty neat, and it was really effective for the time. People had never seen it. And then in the top right over here, this is Paris, and they actually did this. This is called a chloropleth map, but they they actually saw where, in general, in Paris, all the arrondissements over there, where the outbreaks were kind of located in. So you can see in the southwest portion here, that's a really big hotspot, and then in the northwest. This was all brand new. No one had ever really seen this. So obviously this is all done hand-drawn on paper maps, but it's kind of like where GIS started. So computer-based GIS started in the 1960s, but it was so resource intensive that it was not widely accepted until the 80s. You know, this is back in the days of like punch cards and everything where, you know, let's say you wanted to do a task and it might take you a week or two just to get everything set up and run just to see like the end product, where now I can, you know, make a full-blown GIS web app in like 30 minutes or whatever. So the military developed a system called GRASS or GRASS in the early 80s. I think it was like 82. It was open source because it was federally funded, right? And then it was kind of the basis for all of the desktop GIS software that we use today. This is pure commentary. Don't take this as gospel word, but the GIS industry really, hold on, let me let somebody in real quick. Kyle, I hope you got back in. So the GIS industry really started picking up speed in the late 90s or early 2000s as ESRI became the industry standard and GIS analysts are trained on a single program. That's my commentary. I think it was also had a huge part to do with computers stopped sucking in the late 90s. They weren't like they were today, obviously, but we could finally use the graphical interface and do stuff without having to, you know, just spend a bunch of time dealing with interfacing with the computer. So as computer stuff progressed, GIS progressed with it. Web mapping for the masses really took off in the early 2000s. There's the actual like GIS software that was, you know, being developed, but also if y'all remember MapQuest, I remember before we all had smartphones and I would go visit my parents in Arkansas and I was still living in Louisiana. I would print out paper maps of directions on how to get there. But I would go to the MapQuest website and find all that data. Later on, Google Maps became like kind of the standard for navigation and direction and things like that. So that web mapping is clearly tied to GIS, but it's got a parallel track with it. This is a book that I got a couple months ago. I love this book. It's amazing. It's called Never Lost Again. This guy actually is from Austin. He went to UT, so there's a bunch of cool like Austin references in it. But basically, he moved out to California when his college buddy started this company called Keyhole. And they were trying to develop what eventually became Google Earth. That was their entire business plan. So Google actually bought them in 2004. They had all their Google Earth stuff was already created. They finished it out and produced it as Google Earth, but they really were wanting to crank out Google Maps. And it was just super interesting for me as a GIS professional, as well as someone who like I grew up in that era. So I was in college when the first smartphone came out, the first iPhone in 2007 and all that. And it was really cool just kind of like looking back and remembering how that affected my life as like Google Maps was developed and how like it affected daily life. So check that out. I've got a link here. I'll post a link, or I'll email it or post a link or something like that. You can check that out. It's available on Amazon. It's a pretty cool book. If you want some further reading. Okay, so before modern GIS, and this is going to be back in like the 80s and 90s, you had those paper like topographic maps and paper-based maps, and people would literally put a transparency, it was called Mylar, on top of this paper map. And they would like draw a river or draw where you'd want to build a new building or something like that. So I got this cheesy graphic up here that kind of shows like the graphical representation of what they were physically doing. And then, so I actually talked to one of my coworkers today, and she actually sent me these pictures. These are, I work for the city of Austin, Texas, and these are actually workers in the 80s drawing on Mylars. This guy over here is drawing on the map, transferring it over.
Yeah, that guy actually needs glasses now.
Come again?
He needs glasses now. After...
Oh, for sure, yeah. And I'm sure they're, you know, this is 40 years on now. And so like the middle guy is actually like replicating a map and transferring it over. And then the third one over here on the right, that's a Mylar transparent overlay that you would lay down on a base map. So I think it's really cool to like, just imagine the power that you have like on your phone. These guys would have been like dying to have all that stuff because they wasted so much time doing all this repetitive manual labor. So look at these epic screens. Once again, this is back in the 80s here in Austin. Like this woman here is actually, you would take this mouse, it was like pre-mouse, but I think they called them something different, but you would go and actually click on the paper map and the mouse knew where it was on the table and it would put the data into the computer. So this is how things were done back in the day. It's kind of crazy. I got a couple of links up here. Let's pop one of these open. Just like some, basic history. This is the Esri stuff, so it's kind of like, clearly it's going to have rose-colored glasses favoring Esri. But yeah, so like you can see this guy over here on this map. He's got his coordinate system, and his coordinate reference system is a ruler, which is awesome. And yeah, this is another one of those hands digitizer things that I was talking about, which is kind of crazy to see. And then, all right, so move on. So the current state of GIS, once again, just a little caveat here. I am a proponent of WebGIS, and that's what I do for work, and it's what I'm like specialized in. So this is like debatable. Again, take this with a grain of salt, but paper maps are dead, just like how they said records and print were dead, right? Paper maps are very rare. Most GIS is published to the web. I have a very specific use for this. Anytime I print out a paper map, and I haven't done this since probably 2014, as soon as you print out a PDF map, it's immediately out of date. We live in Austin, Texas. Most of us here on this phone call, so clearly, stuff's being built every day. So if you, imagine printing out a map, it's just going to be out of date. My favorite part about the entire web mapping platform is that, so like you can have a map located at a URL, linked to a website, whatever, it's living there. I can provide the scenes, update that map. Nobody knows the difference, but that map is in real time. That's a very cool thing for me, and it's very easy to do. Proprietary GIS uses Amazon Web Services, so you don't need programming. Back in like the early 2000s when WebGIS was like kind of finally getting rolling, you kind of had to have some very specialized skills to get that up and running on the web, but it's really easy to do now, like anybody can do it. It is very easy and inexpensive to get set up with a GIS environment for personal use, and that's what I'd like to talk to you all about later today. I have a couple of examples of what I use for my personal life and professional life, and then there are a lot of open source tools and apps that are much more user friendly. So that first sunrise tweet map that I showed, that was CartoDB is the web platform. You can like literally just log in, get a login. I think there's like a paid version, but you can create and host GIS data just like fully from the browser. Mapbox and Leaflet are kind of like the two main sources for open source base maps and web map stuff on the open source side of things. And then I think what some of you are here for is like you're kind of looking for data. There is so much free data that is published by government entities that people just don't know about. And hopefully we'll pop up in a couple of these things. The census data is huge, right? So actually, Pat, my dad, we were talking about zip codes earlier. The Census Bureau maintains this huge GIS database of like state polygons, counties, census blocks, all that stuff. So you would never have to recreate GIS data at that level. You can just come here to the US Census Bureau and download all this GIS data. And I do this pretty regularly when I'm trying to get like county data, parish, whatever, things like that. So census data is huge. The USGS, the United States Geological Survey, they clearly are all over the nation and generating all of this natural sciences data. There's so much data here. Check it out. It's pretty awesome. At the state level, I'm going to focus on Texas because that's where I live. We have the TNRIS, which is the Texas Natural Resource Information Systems. They're awesome. Actually, one of my neighbors works for them. They're really cool people, but they have like a bunch of really cool data. They also have historic data. So Steve, I think you're on the call. They have like a bunch of old Austin flat data and things like that, where you can go and kind of like do some reconnaissance on like your land or things like that. It's just like a wealth of information and historic data. It's really awesome. They have like more recent data where they do like remote sensing, like LiDAR, things like that. You can see it here on the screen. Texas Parks and Wildlife, TPWD, they have a ton of data, clearly. If you want to look at that. Texas GLO is the General Land Office. They have a ton of data. I'm always surprised, like I don't think of them a lot, but when we see them at conferences, they always have all these really cool things they're working on. So all of these organizations have this data that it's completely free, right? This data is paid for by tax money. So like anytime I'm doing work, I'm being paid by y'all. So this data that we're creating as GIS professionals, it's for you. It's for you guys. So go down here, download whatever you want. This is the open data portal for the city of Austin. There's like, street segments. There's stuff about watersheds, transportation, water utilities, just like all sorts of stuff. It's all here. And I think that might be useful for clearly Kyle's on the city council. I'm sure he's going to be interested in that local data stuff from Fayetteville. Austin and Travis County. Austin is so big, it's basically the same thing, but they're completely separate entities. My friend Tim actually works for Travis County, and they have a lot of GIS data that they generate. They mostly deal with kind of the outskirts ETJ of Austin area that isn't completely in the city's jurisdiction, but they have a ton of data and a lot of resources there. All right, so I'm going to get into some cool examples. So just a little update. So it's 7:42. I'm sorry, I'm taking forever. I want to jump into some cool examples of just stuff that I like to look at, and then we'll hop back and you can ask me questions, or if you missed something, or if I was talking too fast, let me know. So the first thing that I want to look at is this. I'm going to clear out some of these tabs because this is crazy. So this is the biking application I was talking about earlier. It's called Strava, and I just am in love with it. I'm a huge nerd, if you haven't already figured that out. So just look at it. How gorgeous is this? So this company started in Seattle, and they're clearly a fitness tracker app, right? But they actually built out a GIS team there, and they make the most awesome stuff. And my favorite part about them is they give this data to the cities to use in city planning. So once again, it's like kind of this data is kind of tailored towards fitness riders, like sport riding, but it's actually pretty useful in terms of where people are actually riding versus I don't know where people are riding. So just a real quick overview. This is worldwide. Clearly, you see stuff in Japan, Europe, Australia, Africa, everywhere, right? No Antarctica yet, I guess. So anyways, I'm going to come down here into Austin. And this is, I'll just kind of walk you through some of this stuff. I use this, I don't have to use this in Austin very much. I've been riding around Austin for years, so I kind of know where everything is for the most part by memory. But I actually use this application when I go to new cities. I've got a really good friend who lives in Denver, and I'll actually go and then poke around and see where people are actually riding. My main goal here is I don't want to die. So there might be a bike route that maybe the city says, oh, this is probably a good bike route. But if it's pretty unsafe, you will not see bikers ride on it. For the most part, you can see that South First Street has a nice heavy line on it. And I think people are insane to ride on South First on a bike, but it is what it is. South Congress over here has bike lanes. This is the hippie highway, which is how I get to work. 360 is a really popular route. So this is just a really cool GIS application. It has real world implications for me. I'm clearly a GIS nerd, but I use this for not my work, right? So that's a good example. This is a free app. You can download it and check it out. Oh, I did have one more thing to say about that. there's that middle section of the GIS where you can do GIS with these proprietary but free apps like Google Maps and Strava. I was talking to Rick, who's on the phone, and we were talking about, or sorry, I was talking to a coworker of Rick's, and we were trying to figure out how to collect some GIS data in a different state. So I was in Texas, he was in Nebraska, and I was like, well, can you like go find these coordinates? And you know, I really want to know where these, like the extent of this area you're at is. I don't know how to get that data to me in a nice way. Then I was like, wait, hold on, Strava. You've got your smartphone. Could you just download Strava? He did. He downloaded Strava and he walked around the perimeter of the thing that I was trying to map for him. And right there immediately, for free, he was able to give me GIS data. All he had to do was download an app, hit one button, and generate all that GIS data. So that's a really cool way to do some field collection of GIS data using Strava or my Fitness or whatever kind of app that you want to use. Another thing that I use that's not proprietary GIS is is Google Maps. So before the coronavirus craziness started, I was planning to go to Big Bend for the first time going to Big Bend. I was really excited about it. I was going to go on an overlanding trip for a week and live out of my truck. And so I was like, okay, cool. I'm gonna be hardcore, and I'm going to. Oh yeah, Jason made a comment in the chat that Strava records running and biking, and you can kind of filter it out, and it changes the look of the map. But sorry, I'm trying to do multiple things at once here. Anyways, I was like, yeah, I'm going to make a cool map of all the places I want to go because I have friends that have been to Big Bend and they were making recommendations. And I was like, I'm going to be cool and put it in this in GIS that I own, and I'm going to host these maps. And then I'm going with a couple of friends, and I was thinking, wait, hold on, they probably don't have the same GIS stuff that I have. So why don't I build out this map in Google Maps? The cool thing about Google Maps on your phone is that you can offline mode the data, so you can actually download all the data that's in this map. So I have this little blue line is me going from my house down to you know, the Panther Junction area or Alpine, wherever it is. So you go down and enter the Big Bend National Park. But yeah, this is the data I actually care about. So whenever I go on the trip, whenever they let us do stuff again, I'm going to download all this data on my phone. So if there's no cell coverage, I have all that data. Your GPS still works on your phone, even if you don't have cell coverage, because you have an actual GPS receiver on your phone. So with this downloaded data on Google Maps, you can walk around in the middle of nowhere and have this really cool navigation app just kind of built into your phone. That's another reason. That's another reason to use like this free GIS environment stuff. Oh, I had it linked right there. So this is the map that I was talking about earlier that Min showed me, and I'm sure a lot of you have seen it. So this is put together by some GIS folks at the Johns Hopkins University, and it's awesome. Well, it's not awesome. The data isn't awesome, but this is called, and this is an Esri product, so the proprietary GIS. At its core, there is GIS map data, right? So all those points on the map. If I want to see how many cases are in Austin today, I click on Austin and I see there's 642. Those are the attribute data associated with the point. And then this whole environment is really cool because it lets you interact with the map and filter data without having to have a bunch of crazy tools set up or like extensive knowledge. So if I want to just filter all of these data points to just the US, I would come here and click this, and then it immediately filters the data. That's a really cool way to use GIS and make it more powerful by using visualizations and things like that. One thing that I didn't really go over is OpenStreetMap. So this is a really cool thing. Clearly, you have base maps from Esri and Google and everything. They're paid people who create those base maps. Very labor intensive, and but it's very tightly controlled because those companies actually are creating and paying money to make those base maps. OpenStreetMap is 100% open source. So like any of you on the call can go and make an edit. So like if there is a new road that's built in your neighborhood, you can actually log into OpenStreetMap and like edit this as a user. And it's just completely crowdsourced. So that's a really cool thing. Oh, wow. Okay, so one more thing about GIS platforms. This is an open, I'm kind of getting in the weeds here. I could probably save this, but this is an open source way to make web maps. GitHub is a popular repository for like coding and things like that. And you can actually upload a GeoJSON, which is a interchange format of GIS, and map completely free on the web. You click on this polygon that I made in GIS, you can actually associate attributes and hyperlinks, things like that. That's kind of getting a little over, a little beyond our scope here. But anyways, I know that was a lot of information. I'm sorry to like completely overwhelm everybody. I do apologize. So I see that there's some chats, questions rolling in. Is there anything that I said that I kind of glossed over or missed or anything? Please let me know. This is, you know, I'm just kind of describing what GIS is to me and how it might be useful to you. But please hop in here and ask me some questions.
Hey Matt, before
Yes.
jumping into,
Oh, what's up, Eric?
hey, what's going on? Before we jump into the questions and whatnot, I have to go, but just wanted to thank you for running this class.
Yeah.
You did a stellar job, and if we do any of these in the future, continuing from this, I'll be joining those as well.
Cool. Thanks, Eric. Yeah, I'm recording it, and we'll have another one. They're the dogs, yeah. Riley, we'll do another one next Friday. So.
Okay, awesome. Well, again, thanks a lot, and I'll see you next Friday.
Thanks, Eric. I'll talk to you later.
All right, have a good one.
Yep. Riley, please stop. So, Steve, before we get into more questions, the Texas Railroad Commission, okay, so I'm trying not to get political here. They do really weird stuff that's not like, so they're I don't fully understand what they do, but they're not railroad related. I'm sure they have GIS data, but what are you looking for specifically? I might be able to point you in the correct direction.
The Railroad Commission regulates oil and gas in the state.
That's right. That's what it is. Yes.
And so I was just curious. Anyhow, it's a long story, but I was just curious if they had, if you knew if they had GIS data.
I am 100% sure they do, but also like GLO is a big one. There's a lot of random data that I wouldn't think they would do. So
Yeah.
I will look into that. If you have anything specific that you want to look for, I can definitely help you point in the right.
Well, I may end up Googling or going to the Railroad Commission site and
Okay.
figuring it out, or the land office site. One more thing, you mentioned the old days. I did a lot of real estate stuff in the old days, and
Okay.
you would go down to the city of Austin, and they had Mylars of
Yes.
topography and 2-foot contours, and then they had lot line, property boundaries. And you would actually tape those two maps together, getting them aligned as best you could. And then for $2, they'd print you a blue line, the old-fashioned blue line out of that. And
So-
it was a very good way to get information, but it was a pain in the ass.
And so you could actually just go like buy these, and they had them like hanging up or something.
Well, they had them all in drawers, and you'd pick out what you wanted and align them, and then give them to the guy at the city, and they tape them together as best they could and run them through the blueprint machine and make.
Yeah, I love that. It's so crazy to me. Like we kind of bitch about, like something goes down, like the web map doesn't work or whatever, and I'm like, you guys don't know, like what they used to do and all this stuff. It's really cool to see like how far it's come in, only a couple of decades.
Yeah.
Cool. Yeah. Is there anything else that anybody was curious about that I talked about? Be like either further explanation or just kind of like further direction? Let me know.
So Matt, when you're making these kind of maps, what file types or extensions do you see?
Cool. Yeah. I'd like to thank you for that question. I'd like to talk about it a little bit. So there is, okay. There are so many file types, right? As you can imagine. The old type of Esri, this was a proprietary file type that has now become what I consider an interchange format, like a universal type. It's called a shapefile. I personally hate them. They're terrible. They create a folder when you make them, and it has like 50 files in them, and it should just be one, right? So it has your actual GIS data as well as your projection and all this stuff that kind of comes along with it. And then there's a lot of downsides to it. I'm not going to nerd out about it, but so if you ever hear the word shapefile, that's kind of like synonymous with a GIS layer, like a data layer. But that is actually an old format. What they use now is called a file geodatabase feature class. It's a lot of words. But anyways, there's a lot of benefits. The storage capacity of the file is much bigger, and then it's like, but the file is actually smaller as well, and then you can store more data in each column in the table, as well as a lot of other benefits. So that's the proprietary version. That map that I pulled up briefly is called a GeoJSON, and let me see if I can.
Yeah, I've heard of JSON before.
Okay, so yeah, this is really cool. This is actually, so there's JSON, which is a JavaScript, or sorry, it's like a web browser file. So I don't know if you can see this, it's not wrapped properly, but so notice this file. Do you see this, how big this file is? It's like really small.
Okay.
This is the entirety of that GIS layer that I published over here in this map.
You're still showing us the
PowerPoint.
slideshow.
Oh, thank you. Appreciate it. Let me
You
share.
popped open the new
multi-screens?
window.
Sorry,
Yeah.
we're having a total fail here. So I want to do this. No. Okay. Can you see this?
Yes.
Okay, cool. So, anyways, this is a text file. It's a JSON, but it's a specific JSON called a GeoJSON. But this includes the entirety of the data that I showed on that web map, which is just really cool to me because, like, when you get into a really big GIS layer, it can be like megs to gigs, right? It can be this huge amount of data, and then this GeoJSON open source format is just the text, just the attributes, and just the vertices of the polygons and points stored here in text. It's very light, and it like you can display maps really quickly with this format. It's really cool. So just a couple more of those like open source data formats. I mentioned Keyhole, which is what turned into Google Maps. So if you ever heard the term KML or KMX, that is Keyhole markup language. It's what Google Maps uses to draw all their point signs and polygons. But you can, so like from my proprietary Esri GIS, I can export from a feature class into a KML or GeoJSON or shapefile or whatever. So there's also these really cool online websites where you can, it's all open source, where you can say, I have this kind of file, convert it into this type of GIS file, and then it'll do it automatically. So those are the different types of GIS files, but we mainly work with feature classes, shape files, and yeah, GeoJSON is probably a pretty popular one.
Cool. Oh, funny anecdote too. You were talking about the Fitbits and all those kind of things.
Yeah.
A kid in Australia found all of the Middle Eastern military bases from the Allied forces using that data.
Yep, from Strava. Yep, I heard about it. So about a week after that story went viral, they made it to where you had to log in to see a certain scale on that global heat map that I showed. It was pretty funny watching that whole thing. Yeah, it happened while that was going on. So. Awesome. Jason, I know you can't talk, but did you have anything specific to ask? I know you were kind of curious about mapping and things like that. I hope this was helpful for you to kind of like get you thinking about what you might be able to use for the bike map data. But yeah, I think the next session that we do, which is going to be next Friday, will be also pretty helpful for like how to get started and all that. But feel free to, you know. Yes, definitely. Okay, so this is a really good one. I actually can describe how to do this. Jason asked, will you cover how to get data from Strava or Fitbit into GIS programs? So yeah, we can actually walk through that next week, but I actually do this for work because we get like time off if we exercise. which is, I think, a really cool thing that the city does. So thank you, City of Austin. But basically, I take my Strava data. Oh, and this actually answers Drew's question a little bit more too. All of those old navigation, well, they still exist, like TomTom and Garmin and things like that. They developed their own file format where they collect GIS or GPS data, I'm sorry. And it's called GPX, or there's another one that starts with a T, TCX, something like that. GPX is another one of those like standard universal formats, but it's pretty much only used for GPS devices. But yes, you can convert your Strava data into a GPX, and then you can convert GPX into a shapefile or whatever. So that's actually how I did it with the other guy. So Rick, I'm not sure.
And that's similar.
Go ahead.
I was going to say, similar to the Strava bike data, have you ever done anything with like the ski data or like from something like Ski Tracks? Have you ever heard of that app, like for downhill skiing, like that had elevation too, in addition to maps? Because I see that pretty cool. When I went skiing recently, I just discovered that like a few months ago. I thought it was really awesome. I was wondering if you've ever seen that.
No, for sure. Yeah. And I don't know if you can see this. Hopefully I don't have any weird stuff pulled up right now.
I can put it in the chat too.
Yeah. Actually, I just kind of want to show you, like this is the biking app that I've been talking about, and my buddy crashed. Too bad. So like, where's the long one? Yeah. So this is a ride I took. I don't know when this was. Doesn't matter. So one of the cool things about the Strava app is it plots elevation across your ride. Okay. So if you notice, this is my ride, right? So this is the GIS data that my phone collected, the GPS data. So do you see down here where my mouse is? So this actually records your elevation as well. And we could actually do an entire thing on like how this all works and how it knows what your elevation is. But so if you were to go to, the Strava doesn't work on a browser, obviously. You actually have to, there's export GPS, X button. You have to have it on your phone, but you can actually go and say, I want to snowboard, and they just added this functionality, I think in the last year or something. But so when you go to record an activity, you can actually do snowboarding or whatever. You can actually, people do like canoeing, random stuff. And so here's the app. Oh man, my virtual background's messing it up. You can't see it, doesn't matter. Yeah, you can select what you do, but I think the elevation data is really cool. So like for bike riding, it's kind of important because like if you have a big hill and you're really tired, like you've run 80 miles or something, you'd want to know about if you could avoid that hill, you know, things like that. But yeah, so cool. Anybody else? Kyle, I wanted to put you on the spot. Was this useful at all to you, or do you have any more questions? Is there anything that you'd like to know more about, or?
So I am an avid do-it-yourselfer, and I'm a pro at using the wrong tools to get stuff done. So I have a question, or I have something I want to communicate, and I find a way to make it work even if it's ugly.
Fair enough.
And for a while, I was using the Google Fusion tables and could do some pretty cool stuff with that, but they discontinued it. And so I've done things like take all of our appointed board and commission members for the city for our 14 different committees and map them to their addresses around town and show that, hey, look, our entire west side of town has nobody on Parks and Rec.
Okay. Yeah.
That's the kind of stuff that I've done as far as location based. I'm really kind of looking for how to dig a little deeper into representing data geographically. In particular, one that I'd like to pull together in the next week or two is crime stats before and after stay-at-home orders.
Interesting. Okay, yeah, for sure. So if you want to hit me up before next Friday, definitely. But we'll actually kind of walk through setting up GIS on your computer, as well as doing web stuff. So yeah, let me know if you need help. But I definitely think you might be interested in the next one. Man, I thought of something and it's completely gone now. So let me see. Do you have good data? Well, there, like you have access to the data. It sounds like.
I installed QGIS yesterday, and
Awesome.
this morning
Very cool.
I figured out how to connect it up to the city's web service. So all the stuff that I've been asking for raw data access that they just kind of hem and haw about, I snuck my way in the back door and.
Dude, good for you, man. That's like really awesome. I'm very impressed because we have a very active city council here. Like they're very involved also, and they're very thirsty for data. And they're the same way where they're always asking for stuff. So keep on doing that. That's great.
I get annoying and I bug the staff, so I like it when I'm able to pull it out and do it myself because
it's a fine line to walk, I'm sure.
Yeah.
So actually, I just remembered what I forgot already. Saying that you like to solve things with the wrong tools. My coworker and I, we both have a GIS background, but we were working with. This is very boring. We were doing some SharePoint work today, some Office 365 stuff, and we both were like, okay, so we have this table, we have this other table. We need the data from over here. Okay, let's just do it in GIS. So because GIS is a relational database-based program, you can actually do a lot of this data transfer stuff within GIS in a really easy way, just because like that's how GIS data works. So you actually can take your flat files, like if you have an Excel sheet or a CSV, whatever kind of just table data you have, GIS is a really cool way to like manipulate that data, even if it doesn't have a geospatial component. So I'm also the same way. There's this saying that, I try to solve everything with GIS, even if it's not appropriate. So I'm a hammer and everything's a nail with GIS.
Yeah, so if I can write a SQL query for it, I have. So I understand.
Awesome. Very cool. Cool. Pat, did you learn anything about GIS that you didn't already know?
I doubt it's anything you haven't already told me at some point.
So I'm really curious. I know you talked about logistics a lot, but I'm curious to see if the GIS environment that I work in a lot, do you see a use in your workplace, or is it going to be kind of like very like operational, real-time logistics stuff?
So what I think is of interest is, some of the sensors, some of the sensing technology some of it's already been developed, some of it is continuing to be developed. Integrating the sensor innovations into location and tracking it by time. It's making it live, so anything that is moving, you can see where it is and when it might arrive at a location. And I know that is going to generate a ton of data, but I think I'm interested in that component for sure.
Cool. Yeah. So I can speak to this from the proprietary Esri side of things. They have this product called a Geo Event Processor. And so it just sits there on the web, and it just, you give it a URL of where your data lives, and it just waits for data to come in. And then it does, it's a series of tubes, right? It does all of its stuff on the server side, and then converts your data that's coming in. It could be text or whatever, and then forces it into a map and makes it a GIS product. So that's definitely available, but you have to have obviously your GIS environment set up.
Yeah. No, it's good stuff. Thanks for doing this.
Yeah, awesome. Cool. It's 8:10. I can be here as long as you want. I got a beverage, and but yeah, just if y'all have any more questions, let me know.
Thanks for putting this together, Matt. It should really help me talk to my GeoInc guys a little bit better.
Cool, man. Yeah, thanks for coming. I could talk about this all day. So, awesome. Thanks so much. And yeah, if y'all are interested in actually like getting going on GIS, definitely come back next Friday. I'll send out another email. I'll probably send out like a survey, so I'm not spamming everybody from the first group. But yeah, let me know, and we'll talk about. We'll probably do QGIS like Kyle was talking about. Where you set up this open source GIS. It's actually like pretty easy to do. It's all free. But then there's also, I use a home version of the Esri software. It's actually really cheap. I host web maps for my own personal projects as well as some other people. It's $100 a year to get a full desktop software as well as your web hosting. So I feel like that's a pretty good deal. But anyways, we'll kind of talk about all of that stuff. And if you just want to go completely off the rails and be a badass code developer person, you can use GIS, GitHub, Google Maps, all sorts of things to just host your data completely in the browser without needing any sort of like desktop side software. So that interests you?
So, Matt,
yep.
Hey, Matt, I saw a question come up on the chat. Are you going to send out a deck? I missed some of the visuals because I was driving, so.
No, for sure. So that Google slide deck that I was presenting on, I'm going to send this out. I've already shared it. It's public, and so we'll this will be sent out as a link, as well as I'm recording this on Zoom or whatever it is. So I'll put the video on YouTube or something and send it out as well.
Excellent.
Awesome. Well, cool. Thanks so much. I'm not trying to get everybody out of here, but if no one has any more questions, I hope you all have a great weekend, and thanks so much for joining me tonight.
Thanks again for doing
that. Thanks, Matt.
Definitely.
Sure.
Thank you, Matt. Thank you, Matt. See you next week.
Your
Thanks so
enthusiasm for GIS is contagious.
Oh yeah, yeah. No, I do love it. So, all right, I'll talk to you later.